It's question show time. Your questions, my answers. As always, wherever you are, anywhere on my channel, if a question pops in your brain, write it down. I'll gather them all up and I will answer them here. So a couple of things. Three things. One, we've got another special guest answerer this week, Dr. Becky, which is awesome. So stick around to the end to see that. Two, everyone was wondering if there was a hummingbird in the shot last week, and there was. This is our hummingbird feeder. You can see it's wrapped up with lights to try and keep it warm because it freezes solid if we don't do that. But as long as we keep this thing going, the hummingbirds show up. And so maybe we'll get a hummingbird show up during the show, who knows? And number three, I've had a bunch of people say that they don't understand all of the things that I do. So I thought I would just quickly give you a list currently so that if you're wondering if you're missing some content, right? So here on this YouTube channel, I do the open space, sort of the live interview every week. I do the question show, which you're watching right now, and I do a scripted guide to space video, which is the one that's all just like full screen with graphics and pictures and things like that. I'm also a co-host on the weekly Space Hangout, and we do that every Wednesday at 5 p.m., but it's also available as a podcast. And I'm a co-host on Astronomy Cast, which I've been doing for 500 plus episodes with Dr. Pamela Gay. So, and occasionally I also live stream, sometimes on Twitch, from a telescope, which we call the virtual star parties. So I'll put links to all of the things that I do down in the show notes, and that way if any of those sounded interesting to you and you were missing parts of them, then you can go and collect the whole set. All right, let's get into the questions. William Johnson. Hey Fraser, what would happen, say, in 3 months or so if Opportunity phoned home and said, "Hi, I'm alive"? I think we had a satellite do that a while back. They declared it lost, dead, and months later it phoned home. Hopefully by the time you're seeing this, my episode on Opportunity has come out, and that might explain a bit. But so the difference with Opportunity, right, is that they knew that the rover was degrading. It's not that they lost contact with it, but they could see it degrading. And they also knew what would take it out, which was a very long period of no illumination on its solar panels, matched with cold temperatures. And it got both. The storm that hit Opportunity was the worst global dust storm that we've ever seen, and in fact it concentrated right over Opportunity, and NASA knows exactly where it is and has sent hundreds and hundreds and hundreds of attempts to regain communication with it. So is it possible that they could find it again in the future? Maybe, but it would mean that it's been taking care of itself completely autonomously for, you know, eventually for years, and then was somehow able to send a signal back. It's way beyond the warranty. Spirit died a long time ago. The likelihood of it being able to come back now is very low. So I don't think we're going to see from it again. HPA 97. Could there be stray star system planets, anything between two galaxies, far enough away from any galaxy that it would be difficult to assign them to a specific one? Yeah, absolutely, right? A galaxy is just a concentration of matter, a place where there was material and that material dragged in more material, and then there was more material and it dragged in more material, and you just got this big concentration. But you could absolutely expect to find places in between the galaxies, in the vast cosmic voids, where some single cloud of gas could have come together and formed a few stars, or maybe a single star. You would expect to find those out there, and it would be it wouldn't feel that different. They wouldn't see any other stars in the sky, so I guess that would be different. But if there were astronomers that did live there, they would eventually build telescopes, and then they would start to see galaxies. So it would be a very different experience. But then, right now, most people live in such light pollution that they don't see the stars every day, and so they don't really think about it. So, I don't know. It's an interesting idea. But yeah, you would expect to find stars with planets in between galaxies, not connected to any one, just not concentrated in the way that they are in galaxies. Us Mazeneck. Show us Chad sometimes. No problem. Chad, say hi to everybody. Chad, of course, is the editor of these episodes. Chad and I went to college together to take computer science, and then he went off to become a computer programmer, but he was always doing video production and editing, and a couple of years ago we needed some help with this show, and I know Chad was doing some video editing, and we always got along really well, and so I invited him to help out, and he's been editing these videos now for years and years, and we really couldn't do this without him. So thank you, Chad. And actually, I'm planning to do an open space, if he's up for it, where it'll just be Chad and I talking, and we can talk about the production of the show and hear people's suggestions on how we can make this better and topics and things like that. So stay tuned for that in the future. Mauricio Togneri. Hey Fraser, if we know when the universe was created and we know its rate of expansion, why are we able to calculate the size of the entire universe? That is a great question, and the problem is that we don't, there's sort of two parts to this, right? The problem is that we don't know the size of the universe before it started expanding. And I know in our minds, right, we have this idea that it was this microscopic little ball, right? Like something smaller than an atom, and then the expansion happened, and then this ball grew, and we see the ball the size that it is today. But that's not accurate, right? What it was the universe was some size. It might have been infinite in size, or it had some size, bigger, right? And then the universe started to expand. And what we see as this sphere around us is not the size of the universe, merely like a time machine that shows us the amount of time that various spots in the universe are able to send their light so that we can see them. And so when you hear a sonic boom, or when you hear some loud sound, right, you're not hearing that sound as it happened. You're hearing the sound seconds ago, and then the sound takes time to get to you. And so when we are looking around and we see, say, the cosmic microwave background, we are seeing really just this echo from the Big Bang in all directions. But the reality is that if you could go out to that place right now today, it would not be what's there now today. It would be whatever was there 14 billion years later. And so, yeah, we can absolutely calculate how the universe has been expanding, and that's how astronomers have figured out the age of the universe. Is you just run the clock backwards. You know how big it is today. You know sort of what it must have looked like in the beginning. You calculate how long it took to get from then till now, and you get the age of the universe. But just imagine the universe not as this little atom, but just as this potentially an infinite grid that just expanded. The density of the grid went down. The space between the lines went down. But it might have been much, much bigger than the universe as we understand it today, or maybe it was infinitely bigger. And right now, astronomers have no way to calculate how big the universe is. They can get a sense of what its minimum size must be, somewhere in the hundreds of billions of light years based on the curvature of the universe that they're able to measure, but they don't really know the actual total size, and may never know because we can never detect that curvature. So it's a interesting mystery. Lawrence Bell. Least toxic comments section on YouTube. Right? It's amazing how good the comment section is here. And I hope it's because I'm able to be active and participate and show people that this is a place that they'll be able to get their questions answered and that we can have this kind of conversation. And I think just a lot of credit goes to all of the people who have this positive, even-tempered attitude in the comment section, who are willing, if someone, it's amazing to see what at sort of at a glance looks like it's going to be this awful argument, right? You see someone make a comment and then someone posts another comment and another comment, and you see them pile on, and then you actually read and you're like, oh, what a nice conversation is going on there. So everyone who's in the comments, keep at it. I really enjoy being a part of it. I enjoy reading what you write, and I like that people can get along. So keep it up. Andalula922. Great show, folks. My question is this. If the solar system formed from the gas and dust of prior supernovae moving in random directions, where does all of the rotation of the solar system come from? Also, do all solar systems rotate in the same relative direction? Great question, and the answer is no. All of the different solar systems across the entire Milky Way rotate in completely random directions. And what sort of sets up the orientation of the star system is you've got this great big cloud of gas, and if you were to take each individual atom and set it aside and measure its direction, it's moving this way or this way, right? And you just like added up that number. And then you took the next atom and you calculated all of its. And if you added up all of those numbers, you would get essentially the final orientation of the star system, right? So all the atoms are moving around in this great big cloud, and they're glomming onto each other, and they're starting to form this sphere. And then as it starts to pull together, and you've got this averaged out momentum from all of these particles, then this thing starts to spin in some random direction. And the old figure skater pulling in their arms, as they get closer, they go faster, right? And so as the gravity starts to pull the thing in, then it starts to spin up faster and faster. And what direction it spins is really just the average. It's a random pick when you add up the motion of every single particle. It's an amazing idea to think about. Rob Carmick, panspermia happening only once? Maybe you're right, but I don't think so. Panspermia is this idea that at some point in the ancient past, right, that asteroids smash into, say, Mars, and they kick up, or Earth, and they kick up rocks into space, and the rocks move through the solar system, and they end up and land on a different planet, and then life takes hold. And so if you go far back enough, you might find that life on Earth and Mars are related, which is an amazing idea to think about. And in fact, if we find life on Europa, maybe that life is going to be related. And you're exactly right, that if this process could happen once, then this process probably could have happened many times. And you could imagine a rock smashed onto Mars and kicked up meteorites into space, and the meteorites went through space and they landed on Earth, and then a rock hit Earth and kicked up meteorites and they moved back to Mars. And in fact, there's an idea even of a galactic panspermia, that planets are moving, or star systems are moving through the galaxy and leaving a trail of debris behind them, and other star systems could be moving through these debris trails and depositing life. And that might be an explanation for why life on Earth formed the moment that it could have. So if it can happen, if a thing like that can happen once, then you would expect that thing to be able to happen multiple times. And really, again, until we find that first life form somewhere else other than Earth, and figure out, is it made with DNA, and try to find a common ancestor, we won't have any idea what is the history of life here on Earth as it relates to the rest of the solar system. And that's why finding that first life form on Mars or Europa or Enceladus or wherever is so important. We've got to find that other data sample to then be able to move forward and start to form a picture of where life came from. Michael Murphy, could the random collisions of molecules cause a black hole to form on Earth, and would it eat the planet? Planet Earth has been here for 4.5 billion years, and we haven't gotten a random black hole to form inside the Earth and consume the Earth. So we can assume that it doesn't happen. And the one mechanism that could maybe make that happen is cosmic rays from space. They're these sort of heavy particles that are accelerated to enormous velocities by supernova explosions or supermassive black holes, or in fact, astronomers don't even know, but they crash into the atmosphere with just tremendous velocity, and it appears that the most energetic of these could theoretically compress particles and form microscopic black holes. The issue is that if they did that, they're going to have the velocity, they're going to have this velocity imparted to them by this particle, and it's going to kick the black hole through the Earth and out into space. And so if that process is happening, the black holes are being ejected. And so scientists have thought, well, maybe there are places in the universe where these cosmic rays can crash into something that wouldn't be able to kick out the black hole. And one idea is, say, white dwarfs and neutron stars, which are already incredibly dense, and if the cosmic ray hits them and it kicks out a particle, the black hole won't be able to escape, and so it will gobble up the neutron star from within and make it disappear. And so that's like, there are some natural ideas for how you could get these microscopic black holes to form. But then, of course, the other thought is that these black holes will evaporate almost as quickly as they do form. So far we have no evidence that any microscopic black holes can form, do form in any natural way. The only sort of agreed upon way of, you can really call that, is that they would be left over from the Big Bang, that there was this moment in the early universe when space was compressed so tightly that there would be overdensities and underdensities, and in some of those overdensities you could have regions that black holes could form at all kinds of masses, Earth-sized asteroid mass, solar mass, and then as the universe continued to expand and grow less dense, then those black holes would be released into the universe. But so far there's no evidence that they exist. Laucho's reviews and vlogs. What would it take to actually repair Opportunity, or any of the other myriad of Mars rovers that didn't make it? A lot of the spacecraft and rovers sent to Mars hit really hard and smashed up onto the surface of Mars. So they're gone. We're not going to try to repair those. But when you think about like what's wrong with Opportunity, it probably needs a new battery, right? The battery power has degraded a bit. The solar panels are probably pitted and are covered in sand and dust and will need to be cleaned off and maybe put some new glass on top of them. It could use some new bearings on its wheels, I think, especially with Spirit. Spirit lost 2 wheels, so you definitely want to replace the bearings on Spirit's wheels. But it's probably not that much. My guess is if NASA scientists could get their hands on Spirit and Opportunity, they could get them tweaked up and operating again with not a lot of work. But the issue is and so you're like, well, why don't we just go and try and find them and fix them, right? But it's like, to send a mechanic to Mars to fix Spirit would be vastly more money than just to send another Spirit or another Opportunity. They only cost about $400 million to build and send to Mars, which is actually a fraction of what Curiosity cost. When you think about James Webb at $8.5 billion, it's not that expensive. So until we actually have a significant human presence on Mars, those spacecraft are going to remain offline. But I wouldn't be surprised. I love this idea that in the far, far future, whatever, several decades from now, a mechanic on Mars takes Spirit or Opportunity, fixes them up, and then either lets them back out onto the surface of Mars, or, I don't know, keeps them in a museum or something, but lets them still roam around, because they'll still work. So it's something to hold on to. So let's see what happens over the next couple of decades. Something else. Why exactly can't you accelerate at 1G for a year? I mean, I'm sure you could do it with enough ion thrusters on paper anyway, because it would require a lot of ion fuel. In theory, every rocket propulsion system can take you to relativistic velocities. You could go 99.999% the speed of light using chemical rockets, using ion engines, right? As you said, all you have to do is thrust with 1G of acceleration for, I don't know, like a year, and you'll be going close to the speed of light. And you would experience 1G of gravity the entire time. The problem is the amount of fuel that you'll need. That we don't have a way to be able to carry that much fuel. And the more fuel you carry, then the more mass that you're trying to accelerate, and the more fuel you're going to have to carry. There was a great conversation on Quora where someone went through with a chemical rocket and just went through each one of the steps. And essentially, if you used up all the mass in the entire universe, you could go about 0.2% the speed of light. So you could go very fast, but you would have to have used up all the mass in the universe as fuel for your chemical rocket. Ion engines are better, but you would still be looking at a significant portion of all the mass of the universe to go some relativistic velocity. And so it's that acceleration for a sustained period of time for you to be able to enjoy that 1G of artificial gravity on your spaceship. And we just can't imagine a way that you could do it today. Now, who knows? We might come up with something in the future, like metallic hydrogen or antimatter drives or fusion drives or something like that. And then maybe that whole idea will come around. But right now, we don't have any technology. We can't imagine any technology that would give you a sustained 1G acceleration for any period of time. Fault Dweller. What would be the possibility of Oumuamua being a Neumann probe? When I think of it, I'm certain that it's not alien, but a Neumann probe would be the only thing that makes sense if it is alien, like a Cedar type of ship, just dropping nanometer-sized probe to work here and continue its journey to other star systems. If it does turn out to be alien, it would explain the speed and lag of radio waves and stuff. Empty speculation, but what do you think? If I was looking to colonize or explore the entire Milky Way, then I would probably build some robotic factory that would travel at a relatively high speed and would do a flyby through a star system. And as I got close to the star system, it would eject a bunch of robo-factories. They would either slow themselves down or do an atmospheric re-entry or something like that, and then they would land and they would produce more copies of themselves, build more of these ferry vessels, and then continue to explore. And eventually you would get every part of the entire Milky Way explored. So that sounds like an architecture that does make sense. And I did mention earlier in the show that it would be really hard to reach relativistic velocities, but to take 10,000, 20,000 years to go from star to star, that's not so bad. If you're a robot, right? They got all the time in the universe. They don't care. So I think that model makes absolute sense. And I can imagine future engineers going, well, here's how the best way that we're going to explore the entire Milky Way. But that said, of course, there's no evidence that's what it is. And unfortunately, until you have any kind of evidence, you have to kind of go, it's probably not, right? It's probably a rock, or it's probably a comet, or it's probably a torn up comet. And until we can find some actual evidence for what it is, it's all just speculation. But I like the idea. Addison Martin. Hey Fraser, are there any objects in the universe that don't orbit anything? Or is it the case that everything is orbiting something if you look at it from the right perspective? Great question, and I will pass that one along to my special guest answerer, most requested guest answerer, Dr. Becky. Take it away.
Addison, I am so glad that you asked this question because this is a bit of astronomy that I absolutely love. So, yes, and also no. So it all boils down to Einstein's theory of general relativity. So he came up with the idea of explaining gravity as anything that curves space-time. So you can imagine that in 2 dimensions at least, like a sort of bed sheet that you pull taut, and then if you say put a basketball in the middle of that, that is going to curve the entirety of that sheet, the bed sheet, and that you can imagine is like curving space-time. So that any then object that you put on that surface, say you then grabbed a ping pong ball and you tried to roll it in a straight line, it would actually follow the curve of the bedsheet and move in a curve. And if you got it perfectly right, at exactly the right angle and speed, you can make the ping pong ball orbit the basketball because you'd send it on a trajectory that would take it all the way around on a curve, but fully come back on itself in the circle again. And so that is what we think of when we think of something orbiting something. Now, the majority of things in the universe are bound in that way. So the moon goes around the Earth goes around the sun goes around the center of the Milky Way goes around the center of our local group of galaxies. Our local group then goes round our big cluster of galaxies that the local group is part of, which is the Virgo cluster. And then the Virgo cluster itself goes around something called the Great Attractor, which is like a cluster of galaxies in the big sort of cosmic web of structure of the universe. So yes, everything is sort of going around something in the universe, but sometimes you get something that's called rogue planets, which I love because it sounds like it's something from Star Wars or something, right? Like this planet's gone rogue. But what it really is referring to is if you have a planet that has been orbiting its star happily for most of its life, something like another planet or a comet or an asteroid or something could come in and perhaps impact with that object with enough energy to actually set it on a different trajectory. So move it out of that orbit on that curved space-time out of the actual system itself, and then sort of plunge the planet into interstellar space. So then it's no longer orbiting around a star, like it's just moving through interstellar space by itself, but it's not like it's, just going to go straight on till morning or anything. Eventually, it will get caught in the curvature of space-time caused by the entire galaxy itself if it doesn't, run into another solar system, the same way that Oumuamua, which was that weird sort of cigar-shaped object that visited our solar system back in 2017, came through, and we think that may have been like a rogue comet or rogue planetesimal on its way, through interstellar space after being thrown out of its own star system and sort of slingshotted around the sun and back out again. Eventually, those objects, though, will be caught by the curvature of space of our own galaxy, and so they won't end up escaping the gravitational pull of anything. They will still be bound to the galaxy. So never mind rogue planets, what about rogue black holes? Stepping it up a gear. So back in 2017, there was this result from the Hubble Space Telescope that showed that the X-ray emission that's usually indicative of the supermassive black hole at the center of a galaxy accreting material, sort of like sucking in material and growing. So all of the friction of that material being sort of spiraled in towards the black hole makes it glow very energetically with X-rays. So when we see very bright X-rays in the center of a galaxy, we're like, yes, there's a supermassive black hole there. In this result though in 2017, the black hole was actually completely offset from the galaxy. In fact, it was actually flying out of the galaxy at about 2,000 kilometers a second, which compare that to the speed the sun goes around the center of the Milky Way is like 15 kilometers a second. So it was incredibly fast. And what I think has happened is that there's been a merger of two galaxies, and those two galaxies both have black holes at their center. And when they came together and merged, the two black holes sort of came together in the center, but instead of merging themselves, have sort of managed to slingshot one of them out of the actual galaxy so that it was no longer bound to the galaxy itself, which is pretty cool that that could even happen. It's sort of like a galaxy-less black hole now in intergalactic space. But again, like I said at the beginning, most galaxies are found in groups or clusters, and those clusters will have a very center, which everything will orbit around. So most likely that rogue black hole that's sort of just traveling through interstellar space will be caught back by the gravity of the cluster eventually. So really, to have anything that is like fully not orbiting something, you have to have a completely flat space-time, right? You have to find somewhere in the universe that is in what we call a void, so where there's literally like nothing around it. And we do see those in that big cosmic web structure of the universe. You do have places that we call voids where there is barely any galaxies found. If you could have something there that was on completely flat space-time and was moving through constantly flat space-time, then maybe it would not be orbiting anything. And we've never seen anything like that before, but just because we've seen it doesn't mean it doesn't exist.
Thanks, Dr. Becky. I will put a link, of course, to her amazing channel in the show notes, at the end screen, and all of that. I highly recommend you go subscribe to her channel, check out more of her videos. And again, thanks to everyone who sent in their questions this week. I really appreciate it. No hummingbird, sorry. And we'll see you all next week.